This is Geometry, Chapter 8, Section 5, in which we will talk about angles of elevation and depression. The two kinds of angles, elevation and depression, are very closely related. In the case of an angle of elevation, it's the angle that you have to look through to look up at something. It's going from a horizontal line straight out from your eyes up to whatever it is you're looking at that's above you. Depression angles, the angle of depression, is the same idea, but instead of looking up at something, you're looking down at something. And it still involves measuring off of a horizontal line. Notice in both cases, horizontal is the key. And a lot of people do depression angles, and they don't put it off of a horizontal line, and then they make a mistake. They get the wrong answer, then they complain. It's not good. So make sure you're measuring off horizontal lines. That's the key to the whole thing. We're going to start with the oversimplified physics problem. We've got a field goal kicker who is trying to kick a field goal from 40 yards away from the goalpost. Now, the crossbar that he's got to kick the ball over is 10 feet high. And he wants to kick it an extra 1 foot above that, just to leave no doubt that it got over. So the question is, what angle should the kicker kick through? Now, we all know that you don't kick a football and it goes straight. It arcs, right? But we're going to ignore that situation. We're going to pretend we're kicking it like a laser beam so that it goes straight to the target. You want to work with the real physics of what's going to go on. Take physics and you'll learn about that. Now, we're looking for this angle. We have an opposite side and we have an adjacent side. But the adjacent side is in yards and the opposite is in feet. So we need to convert this into feet. We could convert this into yards, but then we're carrying fractions, and I know how you all feel about that. So now, opposite to adjacent sounds like a job for tangent. Tangent of our angle, we'll call it x, is 11 over 120. Well, 11 divided by 120 gives me a nice decimal. Take the inverse tangent, and we get an angle of a little over 5 1/4 degrees. Okay. Again, we oversimplified it, but that's okay. We're just looking to get the idea of how to use these things. Okay. Let's look at a depression case. We have a lifeguard sitting in a tower that is 6 feet above the ground. She looks out and she sees a swimmer, and she uses her trusty astrolabe and finds out that the angle of depression to that swimmer is 8 degrees. Question is, how far away from the lifeguard is the swimmer? Okay. You'll notice that when I put my 8 degrees in, I put it down here. Really and truly, the 8 degrees belongs up here. Okay. You're looking from a horizontal line, looking down by 8 degrees to see the swimmer out here. But the problem is now this is not inside our triangle, which makes life difficult. We could figure out this angle, 90 minus 8, or we could use alternate interior angles. Since these angles are, or these lines are parallel, we can use alternate interiors and put this 8 degrees down here. Okay. A way you can think about this is if she's looking down at me using an 8-degree angle to see me, then I would look back up at her and have to use an 8-degree angle also. It's another way to think about it. Once we're here now, we have an opposite and we have a hypotenuse. Opposite to hypotenuse sounds like sine. Okay. We can get a decimal for sine of 8. We can multiply the x over and then divide. And we get that the swimmer is 43 feet away from the lifeguard. Let's do one that's a little more involved. We want to find the height of a tree. Now, we take out our trusty astrolabe. Like I say, everyone carries one all the time. And we look up at the top of the tree and see that our angle of elevation is 70 degrees. We then back up from where we were standing here. We back up 10 meters. And our angle of elevation to the top of the tree is now 26 degrees. Okay. Hopefully, you see two right triangles involved. You have a small one where we were originally standing, and you have a bigger right triangle where we backed up to. Okay. And then one other piece of information is that my eyes are 1.67 meters above the ground. So we'll use that at the end to find the final height of the tree. Now with our two right triangles, we're going to write two equations. Okay. From the 70-degree angle, the opposite side is h, the adjacent side is x, so tangent of 70 equals h over x. From the 26-degree angle, the opposite is still h, the adjacent is x plus 10, so I can write another equation. Now I can get h alone in both of these equations. If I multiply by the x to this side, and if I multiply by the x plus 10, now I've got h alone in both equations. Well, since h equals this stuff, and h also equals that stuff, I can put the two together. And I went ahead and punched in tangent 70 and tangent 26 to get decimals for them. Well, now I can distribute, get the x's to one side, and then divide. And that tells me that x, my distance away from the tree to start with, is 2.160 meters. Okay. Now that doesn't tell me the height yet, but now I can use either one of these two equations to find the height. I'm going to choose this one because there's less arithmetic involved. X is 2.160, tan 70 is 2.747. Multiply those together and we get 5.934, plus the height of my eyes, which is 1.67, gives me a tree that is 7.604 meters tall. So we had to use two equation tactics to get this job done. But we can handle that. We're good at it. Okay. We've got one more problem to look at on this one. We've got two buildings that we're looking at from the top of a 200-meter skyscraper. Building A, that I'm looking down at the base of that building, has a 41-degree angle of depression. Building B, which is further down the street, I look down there and I see a 35-degree angle of depression. Okay. The question is, how far apart are the two buildings? Now again, just like I did with the lifeguard problem, the 41 degrees really is up here, but I used alternate interiors to move it down here inside the triangle to make life easier to work with. Okay. We still have two right triangles, so that looks like a job for two equations. From the 41-degree angle, 200 is opposite, A is adjacent, that sounds like tangent. From the 35-degree angle, 200 is opposite, and I called this whole side B. Okay. Well, now I can do some arithmetic and get tangent of 41, multiply by the A, and that tells me what A is. A is 230 meters, give or take. I can do the same kind of thing over here for B and find out that B is 285 meters and change. Well, does it make sense to you that X would be the difference between the distance away A and the distance away there B? So a little subtraction, and we find out that the buildings are 55 and a half and a little more, but a little over 55 and a half meters apart. Okay. So a little bit of work involved in setting up the word problems, but I believe in you, you can handle this. If you had questions along the way, as always, I hope you wrote those down, bring them in to ask, and we'll see you in class.